So here we're looking at a multi-stage finance problem. You want to be able to withdraw $20,000 from your account each year for 15 years after you retire. You expect to retire in 15 years. If your account earns 4% interest, how much more or how much will you need to deposit each year to achieve your goals? So again, this is a multi-stage. First of all, you're going to be saving. And over here you can see where I broke it down. You're going to be saving, and then you're going to be withdrawing, or you're going to get a payout. So here's the two formulas. And you'll see in these sections you're really going to use the same formulas. One is where you're putting money in, where D is a deposit or a payment. Sometimes you'll see payment, or W is withdrawal, where you take out. And you can see these are very similar, except here it's 1 plus R over K minus 1. And here we have 1 minus 1 plus R over K. And you notice we have a negative here, and this one's positive, I think. Again, think savings, think payout. So over here, we're wanting to withdraw $20,000 from our account each year. So $20,000 for 15 years after I retire. So we need to think about, okay, well, what does that mean? Well, that means we're going to withdraw $20,000. So that's my W. T is time, 15 years. R is our rate, or the percentage, if we get 4% interest, 0.04. And it's once a year. We're just going to withdraw each year in our account. And so we're wanting to know how much money are we going to need in order to be able to do that. So we're going to look at the payout here. If we're going to withdraw that much at this rate in 15 years, then I need to know how much money we're going to need so I can figure out how much do I need to save. So we're going to do the payout first. And you can see where I plugged in the 20,000. That's how much we're going to withdraw. 0.04 is my rate. Negative, and it's once a year. K is how compoundings times 15 years. And I calculated, and I came up with, as you can see, $222,367.75. So that's how much we're going to need in order to be able to withdraw $20,000 for 15 years at this rate in compoundings. So now I need to go back, and the second part, or the rest of the question, it says you expect to retire in 25 years. We have an account earning 4% interest, and we want to know how much do we need to deposit each year, so annually, to reach our retirement goals. And so now we have enough. Since I figured this out, I have enough now to figure out how much I'll need to deposit here. So again, we plug in to our formula what we have, and this is the initial amount, or this is the future value per se that we're going to need, and so I need to figure out how much am I going to have to deposit annually for 25 years to have that amount. And so you can see where I plugged in our values. This time the 0.04 is the same. This time we're saving for 25 years, still compounded annually, and I come up with I would need to deposit $5,339.49 annually for the 25 years at a 4% interest rate. Now these are very tedious. As you can see, it takes quite a bit of calculations, lots of places to make errors. I'm going to show you how you can use your TI-83 to do these same calculations. So on your TI-83, we're going to go to apps, click on apps. You notice we have a finance app. Click enter. Highlight the TVM solver, which should be highlighted. Enter. And you see we have several things here. You can see I already have my negative 20,000 for my withdrawal. N is going to be the number of compoundings times the number of years. So that's T times K. So that's 1 times 15. and we're trying to figure out the percent is 4%, and you do put it in as a percent. So it'd be a 4 instead of 0.04, which can be confusing because in the formula you're going to use the rate, which is 0.04. Present value, this is what we're trying to, need to know what that value's, that's actually what we're looking for, is that value. The negative 20,000, that's the withdrawals. We're going to be taking that out, so that's a negative. Future value is going to go to 0 because once we draw it out, it's all going to go to 0 after the 15 years. And this is the compoundings per year, which is 1. And both of these are going to be the same for our purposes. So I'm going to highlight what I'm looking for. So as you can see, I highlighted that. That's 0. I'm going to go to alpha, click alpha, and go to enter. And that's because this is the solve. So we get $222,367.75. So you can see that's what we got by calculating. All right, now we're going to figure out how much are we going to have to deposit each year. And this is annually, each year. If it was monthly, we look at 12. So there's, again, things you need to think about as you're putting your values in. So let's see, and this is our compoundings per year. So this time it's 25 times 1. And if it was compounded monthly, you put 25 times 12. Still 4% interest. This is our present value that we're looking at. That's what we just found. Okay. Now that's going to become part of our, sorry, let me get this. That's going to be 0. All right. We're trying to figure out our deposits. How much are we going to have to deposit to get to our future value, which is what this is. In the other one, it was our present value. In this one, because we're saving to get to there, so it's going to be our future value, 222,367.75. Let's go back up and 0 that out. Okay, because this is what we're starting with, which is nothing. Unless, we had money to start, we'd put in there, but we're saying we're starting from nothing. So for 25 years, we want to know how much do we need to deposit, how much do we need to pay in to get to this $222,367.75. Still compoundings annually. Enter, and we get our $5,339.49. And you can see that's a negative because we're going to be paying in our out of our pocket, depositing into our account. So hopefully that was helpful. It takes some practice to know what goes where. Again, present value, future value, payments, deposits, or withdrawals, depending on if we're doing a savings or a payout, annuity, interest, and this is numbers of compounding times the number of years.